Chapter 3 is input and output and system class. So far, we have been using this many times, and so basically we have two things. One is for input, we have system.in, right? And then we usually use a scanner, right? And then we do new, and then assign this to another scanner, input or something. We usually use that for scan input, right? And after that, we say input that next line and assign it to something, assign it to a string. I think we worked on this before for input. And for output, we actually output the file, some data to the screen. And for the output, we actually, so output actually we do system.out.print, right? But here, how many print function we cover so far? How many print function we cover so far? Print and what?
Just print out of line.
Print ln, print ln, and what? Print ln, and there's one more. Which one?
/f.
No, we have one more called printf.
Oh yeah, this is what I say. Some f.
So this one is just print without changing new line, no change new line. This one print with change line. This one print with percentage sign s or something. So it's a formatted print. Okay, so this one is a formatted print. So far we covered these three print. And then print line, we have the escape sequence /n /d / whatever. These different escape sequences can be put into print line and all printf. All the three handle the /n /d part. Is that okay? And then we work on the ASCII art. So here you can actually try this one, system.out.print line, something like that. Let me try this one, okay? Let me try this one. Let me bring up my Bluejay. Okay, this one actually is my son's AP homework, AP computer science homework. Later next year, maybe you will work on it. Now let me bring up your directory. Say here. So always organize your file in one place. That would be better. So Bluejay, now we are in unit 1. Let me try a different thing. Let me put chapter 3 now. Yeah, let me put it. No, I'm sorry, I don't want to do this. So if I want to create a new project, right? I want to create a new project. I shouldn't do this. I should close, and then I say new project. And under the directory, I want to put. I go to my name, and then here, and then here, and then here, and then here, and then Bluejay. I want to put a project over here, so I select Bluejay up to Bluejay as my directory, and then here I put. Let me see. Put here. I put chapter 3. Oh, it should be lowercase. Chapter 3. Okay, now chapter 3 is a new one, and if we check it in my directory PC, and then sugarcane, and my machine name, and then this one. Let me see. This will be close in here. And private lesson, Bluejay. Okay, chapter 3. So when I finish that, I should get something like this, right? I should get something like this. And I jumped into chapter 3. So whenever I create a new project, it will give me the package and readme, right? So last time, why I ask you to delete the sync Java, the package and everything. But actually is to remove these two files. Once these two files are removed, it is no longer a project in BlueJ. The project under sync Java will work. You know what I'm saying? The first one, let's try. We need to have a scanner input, so that's try call the file call input, right? And I believe we actually worked on this before. So let's do this. We have public static void main string, something like this. And before we use it, we actually, this part you can delete or not delete, it's okay, it's up to you. And that one is for documentation. So we have Java util scanner, something like this, right? And then we have scanner, import equals new scanner. And inside here, what should I put?
The output.
Inside here, what should I put?
The
System.in, okay?
yes.
System.in means keyboard. Remember that? So this is a scanner. I put system.in as input. Is that okay? So it's a system.in that is used for input. That's a scanner class. So I actually need to import java.util.scanner. And then I need to have the scanner input, new scanner in right here, right? So a program may have this, it may have a line, and then actually system.out print out something, and then you input a line, right? So that's wrong. The only example it has. So you say type something. So here the next line will ask for in the next line. So I type here, how are you? And then it say type something else, and then I say, okay, I will. And then it say, you say, okay, I will. Okay. So system.in is the input device that actually means keyboard. So basically, you initialize the scanner, and the scanner names the scanner that we in system.in. So system.in means keyboard. Is that okay?
Okay.
Now, I don't want to use keyboard to input. Okay, so this one actually for system.in, here actually I can do like system.out.print, and then I can say, yeah, I have /f, and the next one I say system.in.out.print, right? And then here, enter a file name, right? And then here I say string file name equals actually this input next line. Okay, so input next line will be in the message or a string, right? And I assign that to a file name. And then here I say import java.io.star. And then here I will say, put here with throws exception. Whatever these are just helping us to do something from file. And then I say scanner input equals new scanner. And here I say new file, and then here file name. Okay, and then let me see, new input file name. So what's wrong? Let me see. The input. Oh, I'm sorry. Actually, I should put an F here. File input. Okay. Now, what I will do is while file input that has next. And then I here say system.out.println. I say file input dot next line, something like that. Okay, what will this do? You know, you will see the data, but right here, let me say file input dot close. Okay, and then I finish this, and then I actually go to my directory here, and then go to this, go to this, go to this page directory, go to J, go to chapter 3. Right here, I have the input program, right? My input is over here, right? Over this directory, right? So if I open with some other editor called Notepad, it still would be here, okay? Now, over here, I actually new some text file called aa.txt. Oh no, just AA. And then actually this AA is actually in PC actually is a text file, a TST file. So the whole file name is aa.txt. Okay. So now in my aa.txt, I would say what? Uno, dos, tres. Okay. Cuatro. Whatever. And then let me put maybe this is better. Right? And then I save. I just save it. Okay, my AA.text is now there. Now the next step, what I'll do is, let me close this one. I don't need that one. Now I just run. Okay, so now my scanner input is getting input from my keyboard, my terminal, and my terminal called system.input, right? So over here, we ask for a file name, right? And file name actually will be a string. So here I type aa.text, aa.txt. So after I hit return, it will return to the program and it will assign that file name string as aa.text. And then I use that to create a new file called aa.text. And then I use that as an input file. So originally I use scanner to read in from keyboard. Now I use this scanner to read in from file. So from this file, actually, when that file still have something, I just read the next line and I print that next line's data out. So that means hit return. Got it? So now if I here, I don't like AA.text and I just got EB, right? And here I say ichi ni san shi bo roku. Okay, whatever. What's that? What are these symbols?
Those are Japanese numbers?
Yeah, it's Japanese numbers. And uno, dos, tres, cuatro, what's that? That's Spanish numbers, okay? Now, again, let me run again. And I run. Enter file name, I say bb.text. See? So my program can switch between different input files. Is that okay?
Okay.
Now let me do this, okay? Now let me do this. This one is fine. My project is fine. Let me actually.
So if you let him to search the file for you, this file must be in the same file as
your program. Yes. Now I have this. I have this chapter 3, right? Now I do this. I actually copy this guy. Oh, I'm sorry. I won't copy, won't work. I use this one. Actually, I go to my Blue.js and then chapter 3. I attach to it. Okay. Now you download it and copy to your local. Okay. Now I stop sharing. You share your screen. Now you share your screen. You try to download it and put your local. So I'm trying to exercise that you be able to download a file from my, set it, download it, right? And then copy it to your, copy that zip file. Copy that zip file and then chapter 3. Copy that to your, wait, here you have chapter 3. Copy that file. Copy chapter 3, yes. And then go back to your Sync Java. Go to your Sync Java. No, I need is chapter 3 zip. No. The next one. Not that one. Next one. Chapter 3 zip. Yeah, that one. Copy. Copy to your directory. To your Sync Java directory. To your Sync Java directory.
Wait.
Your Sync Java directory. Maybe not here. Maybe use the your search, global search. Sync Java. Yeah, PD, whatever. Yeah, Sync Java. Wait, you have a Sync Java over there? Okay, right here. Stop. Right here, you pass that zip file over here. And then unzip it. You know how to unzip a zip file? Yeah, maybe archive. Open that. Open that one. Wait, what's going on? Go there. Go into there. Go into there. Okay, you got it. Okay. Now come back next level. Now you use, stop it. Don't do anything. Now you actually change the name of chapter 3 to, change the name because you have 2 chapters 2. So you change the name CH3 from Eric. So you know that it's from me. From Eric. Yeah, it's fine. No, don't do that. Just do it. Okay, keep it there. Then you use Blue.js. Go to your Blue.js. And then open, I'm sorry, go to the project. Open project. And then choose that CH3. Choose that CH3. No, not that one. CH3. And open. Okay, then you run it. You just run it. Okay, type in aa.txt. AA, you have 2A. Yeah, wrong. Got it?
Yep.
So what we have achieved here? You basically download a file from me, right?
Yeah.
You basically download a file from me, and then you actually put in your local, unzip it, and then you are able to run it, right? Now let me teach you some more things, okay? That's one thing very important. The next thing is like, you sign up my course, right? You actually sign up my course for what? You sign up this A course and B course. Probably you only, I don't know. You probably sign up A course. I'm sorry. What's wrong with that? Okay, then you, for example, in this A course, right? You go to whatever, because this is a teacher's view, right? Like it's okay. Now, if for example you go to chapter 2 or chapter 3, let's pick chapter 3, say. Right. So what you will see, this is a teacher view, but the real view you will see is something like this, right? There's a video. You can look at the video, right?
You didn't share screen.
Okay, and then here it may have. Let me see.
You didn't share a screen.
Oh, I'm sorry. Because I actually just, Okay, right here, sorry. So basically, you go to my course, you should be able to come to some class like this, right? Yeah, and there's a video, so let's continue. Let me try to find one like with example. So here, there are a lot of lecture, right? This one don't have code. Let's go next one. Okay, right here, okay. So here, yes, no, happy. You can actually download this one, right? So something like this one, you can just copy and then put into your Java file and it will be able to run, right? And there might be some others. There might be some others, say, let me pick some more advanced one. See right here, right? Here might be some zip file. So when you download, it will be a zip file, and then same thing, you copy to the directory you want to have, and then you can unzip it and run it. Okay? So this course you sign up is very useful. It has the whole thing that you needed for AB Computer Science. Later I'll teach you how to use it more, okay? But today at least we finished that one. Now let's go back to chapter 3. Okay, so we exercise a few things. Refile from a keyboard, then we refile from a file, and then we copy the whole program to your location, and then actually we exercise to unzip it and run your program. We exercise a few things today, okay? You must take notes of everything. And if I finish this lecture, I will create a video for you, and then you should continue to exercise on it, okay? So now let's go back to chapter 3. Chapter 3, we finish, basically we finish this scanner, right? I teach you how to create a scanner, use the keyboard, and also use the file. Right here, it doesn't tell you how to open the file. But me, I told you how to open the file. Now the system class. So system class with system that there's a system.in and system.out. System.in is used for input. System.out is for output. Okay, and system.in actually, if you actually print it, you try to print system.in. Say in my program here after this. So right here, let me try this. Let me try to print now system.out.print. I can print line, I can print system.in, and I also can.
Hello?
Hello? Are you all right? Hear me? Do you hear me? Wait. Hello? Do you hear me? Hello? Do you hear me? Hello? Hello?
No?
Look like you lost your signal somehow.
Me?
Yeah. It's okay. You know, maybe the internet is wrong. So now that we are back. So actually, up to here, I'm trying to print now the system.in and system.out. Okay. And then we compile. And now we run. I'm sorry, we don't get. So we still type in bb.txt or something, right? So you print out two things. It's the input you print now is the input string and the edges, and output string and the edges, right? So what it actually works is like we have our program, right? And then there's a scanner, and this scanner is the input, system.in. Then this one, you will get something into our program. And the location we should get the address, the data is this 1534B something. It's the address for that scanner. And then when you print out, it actually is an object called print string object, and that print string object has this 93A27B address. So when we try to print out that two objects, it should get these two different things. Is that okay? So these are two objects, and the object is easily used for handling the I/O. But right now we have the system.in object and system.out object, and we can also type system.out.print9, and then we can also type this this one called say f input. F input is something we can also print out. It's a scanner of file. So let's type bb.text, and it's a scanner file, right? It has scanner and then give you a lot of information for that scanner. Okay, but that actually is to print out the information for a object. So right here is the system class. So actually system in is a object that handle the input from your keyboard. System out is the object that handle your printout to your monitor. Okay, so we have finished this scan class. And language element, our language element from larger scale to lower scale, we have package. Java.util is a package, and scanner is a class. And inside a scanner, we have main function as a method or function. And each one finished with the semicolon is called a statement. And part of the statement, A equals hour times 60. The hour times 60 called expression. And the lowest unit is a hour. That's only a token. Is that okay? You need to remember these different level of programs. So that's the level of the program. A token are the most basic element of the program, including number, variable name, operators, keyword, parentheses, braces, semicolon. These are tokens. So whatever you see in Java, these are different tokens. Public is a token. Static is a token. Void is the token. Main is the token. Okay, that's called token. And for statement is actually this scanner input, file input equals new scanner, whatever. These are a whole statement. And the right hand side, new scanner, whatever, at the end, this is called an expression. Okay, so the whole sentence is called a statement. Part of the sentence is called expression. Single word is called token. Okay, and then the whole collection of statement is called function or method. And then the whole class is called, this is a class. And many class put into one package. Okay, that's the hierarchy of a program. Literals and constants. So what's literal? Literal is what we talked before. Let me finish this one. This one we no longer need it. Okay, now we create a new one called constants and literals. Literals I teach you before. So literal is something like this. Now we have an integer, and a equals 0x1111 underline 1111. This is a literal. I should put b, and then I do a. So this one is called a literal. The right hand side is a literal. 0b111111. This is a literal. Is that okay? Are you okay with this? Yeah. Remember that 0b is for binary, 0x is for hexadecimal. 0 yeah. 16. This one is binary, is 二进位. This one binary is 二进位. With b is 二进位, and then you have 0x is 16 base. Okay. Now let's compile and run. Okay. So what's the number here?
1 plus 2 plus 4 plus 16.
So it's actually 127. Okay. So 255. I'm sorry, 255. Okay. And if I put it as not putting it as integer, I put it as a byte, and it is not 255. It is minus. Let me see. Here I convert it to byte, and run it. Is -1. Remember that? I teach you this. Remember this one? What's this?
1, 4, 16.
It's actually print. The previous one I converted to integer. It said 255, but this one I converted to byte is -1. Remember what I teach you for the negative numbers? This one's called 2's complement. 2 complement for 1. So if I have a 1, I have this 0, 0, 0, 0, 0, 0, 1, right? 1's complement become this, right? And then +1 become this. So this one is the 2's complement for 1. So this one is x, and 2's complement is a to the power a plus x, and these two plus together, it becomes 0. So this one is used as the negative number for the 1. Remember that one? So that's the called 2's complement. Okay. Yeah. Okay. I just give you some review for this. Okay. These are called literal. The right hand side, these are called literal. Literal are used for constant or something. And if you want to do your constant, here I can put final, static, and then in double, and then say pi equals 3.141159, right? Something like that. And what is a constant? It actually has the final over there, right? Usually, if I don't have final, if I don't have final, I can print it out. I can print this one system out print line, and then I say, okay, I need this pi over here. I print out pi, right? And then I say pi equals pi times 2. So that becomes 2 pi. The pi becomes 2 pi, and then I print out that again. I can print out pi again. So the first pi should be pi. The second pi should be 2 pi. Right, so one is a 3.14, the other one is 6.28. So that's 1 pi, and then I multiply by 2, and then assign to the pi, so pi becomes 2 pi. But here, if I put final, then it doesn't work. Why? Because this guy tried to update the pi. It is not allowed. So final, I'm sorry, here should be final. I take a typo. So here's a final. This one is updated pi is wrong. So final means no change. You cannot change it. So you should have another word called double 2 pi. Then it works. But you cannot update your pi. Your pi is no change if you put final. And those kind of things, we call it constants. So literals are numbers or words or something messages. Constants are something you cannot change. So this one, no change. And I change the result to 2 pi. So I compile it and I run. Okay. And it worked, right? So with final, that any variable with final you cannot change. Is that okay? Hear me?
Yeah.
That's called what? Something with final we call what?
Go ahead. Fine.
No, it doesn't. We call it constants. Constants means that you cannot change. Okay? So something like pi usually is a constant. So here it has the how many inch to centimeter has a ratio of 2.54. Okay, so 2.54 is a constant. You never change that. So you can assign double centimeter per inch. But that one actually is still can be changed. So you need to put a final in front of it, then you cannot change it. Okay? Then 3.5 is like formatting output. 3.5 is actually formatting output. And this one actually, we have double, and then we actually formatting it. If we use a print, it just print out the data, right? Something like this. And we don't want that to have so many different digits. So what we can do is here, if I'm pi is like this, but I don't want to print out so many digits, then actually right here I can put a print f, and then I say percentage like 6.2 f, and then comma. Okay, originally I print out the whole thing. Now I don't want that many digits. So what I specify with that actually give you 6.228 only. So here 6.2 f means what? 6.2 f. What's that? 6.2 f means here we totally have 6 digits. 1, 2, 3, 4, 5, 6. Okay, and then 2. The 2f actually means here we have 2 floating-point digits. Are you all right? Okay, I make sure it's still wrong. And then after decimal point, you have 2 digits. We have 2f. Okay, and then 6 is the total digit that you use. Okay, that's the formatting we have. So right here, if I change to say 8.2, 8.3, I mean, I'm sorry, I should put 8.3 and compile, and I run, it will actually what? Have this 3.23, but 3 digit after decimal point. Okay. Let me do this before we do anything. We still right here. Let's still clean the screen. Okay. And now we finish compile, and then let's run. Okay, so it become this. So let me put it in comparison. If we print the same thing, and we say we are 6.2. 6.2 is narrower and then fewer bits. Let me see. I need to change that. So if you want to change that, you can put percentage n or /n is do the same thing. It will actually create a new line for you. Okay, something like this, right? And if we want to make it align to the left for left adjusted, we put a minus sign before it, and you will create left adjusted. It move to the left. If I don't do the minus sign, it will just assign to the right. it will be right justified. But this one has 6 digits, this one has 8 digits, so they are not aligned. So right here, I want to keep that negative sign to be left adjusted. You know what's left adjusted, right? Are you okay with left adjusted, right adjusted? So you need to know left adjusted. So that's the alignment. When you write something, it has a top adjusted, center adjusted, bottom adjusted, left adjusted, right adjusted. So if your word is adjusted to the right boundary, it's called right adjusted. Adjusted to left boundary is called left adjusted. Center adjusted is like you actually adjust it to the center. Is that okay? So that's the way you print out different things. And in our example, I say that if we use the minus sign, it will be moving to the left. If I don't use the minus sign, it will be moving to the right. Right here, okay? That's left or right adjusted. Okay, then we have this printf. Printf is called formatted string or formatted printout. So here we have a format string, and then put your variable after it. So this can be, we can name it as a formatted string or format specifier, and then basically where the format will specify will be something like this. And it is used to decide if you have a decimal value, then it actually print out a few digits. Are you all right?
Yeah.
Okay, let me finish this 3.5 and that's done, okay? I think you are tired. Okay, right here, we have decimal integer. So with D is used to print integer. With AD, you print out A integer, but with leading zeros. So if you want to put some number, but with 0 in front of it, we actually call it leading zeros. You put a 0 in front of it. You put a F, that's a 14-point number. And then .2, that actually has a 2 decimal point. And then if we have 6.2, actually total width of 6, and then 2 decimal point after it. An S is a string strings. Okay, so that's a formatter. And also Java has a formatter. So we have 3 printout, print, printf, and print9. And you actually print out different way. One with no change new line, one with change new line. And the last one we talk about today is to specify the different printout format. Okay, so right here, we've moved up to 3.5. We will have 6, 7, 8, whatever for next week. So this week you finish the previous few homework. You haven't finished, okay, and send it to me, okay?
Okay.
Yeah, okay, then that's it for today. Bye now.